Video, we're going to talk about rotated angles, angles that are rotated more than 360 degrees. And then we're going to get into how we can convert angle measures between degrees and radians. So to start off with, let's talk about rotated angles. There is a standard position for angles on a coordinate plane. Their vertex is going to be, that corner of our angle is going to be at the origin, 0, 0. The right side of the angle, or the first ray in our angle, where it starts, that's called the initial side, initial being the starting point. So it starts there, it's going to open, and it's either going to open counterclockwise, or it's going to open clockwise, or drop down. That initial side is going to be on the positive side of the x-axis, so if it opens up, that's going to be a positive angle measure. And if your angle drops down or opens clockwise, that's going to be a negative angle measure. I mean, really, there is no such thing as an angle measure that is less than 0 degrees, so that's not what we're talking about. The negative symbol in front of your angle is purely directional. So it's just telling you that it's opening clockwise. The ending side of your angle is called the terminal side. Terminal means end. You could measure the angle in between those two rays, but what you could also do is think about the measurement of the angle on the other side of those two rays. And so those two angles together are called coterminal angles. Co meaning together, and they share the terminal side. So they're sharing the sides of the angles, one's just on the other side. A reference angle is another special part of our angles on the coordinate plane. I'm going to draw an example down here. Let's say that we start with our angle in standard position on the positive side of the x-axis. It opens up counterclockwise, so positive angle measure. The angle measure can sometimes or usually be referred to or symbolized using this theta symbol, this Greek letter. It's the standard symbol for angle measures at this level in math, although not the only symbol that can be used, but it's usually the most used, I guess. So the reference angle is going to be the angle between the x-axis and the terminal side of the given angle. So here's my angle opening that I drew or measured. On the other side, this acute angle between the terminal side and the x-axis is going to be called the reference angle. And the reference angle is going to be pretty important later on when we evaluate trig functions. So for now, we just want to practice making sure we know what it is. Another important thing to get started in our foundational knowledge here is understanding how the quadrants in the coordinate plane work. We have quadrant 1 that we always start with up in the top right corner. The values or points in that quadrant are going to have positive values. The x value is positive, the y value is positive. As we move counterclockwise, we get to quadrant 2. We're on the left side of the x-axis now, the negative side. So our x values are going to be negative, but our y values are still positive. In quadrant 3, both x and y values are negative. And in quadrant 4, we're back to the positive side of the x-axis, but we're in the negative part of the y-axis, so positive x, negative y coordinates. One question we may be asked is, what quadrant does the angle lie in? And so what you look for is you look for the terminal side, that ending side of your angle, and whatever quadrant it's in is the quadrant in which the angle is lying in. The reason why we need to know that is eventually when we evaluate trig functions, they're going to end up in a certain quadrant, and the sign, whether it's positive or negative, is going to be really the only thing that changes in those answers. So knowing what quadrant it's in is going to be important for establishing whether it's positive or negative. All right, let's practice looking at some rotated angles and stating the measurement and practicing saying which quadrant the angle lies in. It's important to note that if an angle ends up on an axis, then we don't say it lies within a specific quadrant. You could say it lays or lies on the axis in which it's sitting on. That's okay to say. All right, so state the measure in degrees and the quadrant in which it lies. Here's our angle, here's our initial side, opening up counterclockwise. We know we're going to have a positive answer. Here's our terminal side where it ends. We're also given this reference angle here of 40 degrees, which is telling us that this angle didn't quite make a half circle. It was 40 degrees less than that. So one way that we can do it mathematically is think that a half circle is 180 degrees, and so 40 degrees less than that would be 140. Always important to double check whether that's positive or negative before you move on. So we're opening counterclockwise, make sure it stays positive. The terminal side ended up in that second quadrant, so it lies in quadrant 2. You don't have to spell out quadrant. You don't have to use Roman numerals for your quadrant names. You could use capital Q and just the numbers that we're used to. All right, here in the second example, we have an angle that's rotating more than a full rotation, so more than 360 degrees. It's also opening clockwise, which reminds us that we're going to need to give a negative angle measure. So we're more than 360. We have an additional 90 right here. And then what's this little piece missing right here? Well, you could say that that's 90 minus 75, or 15. So you could say you have 360 plus 90 plus 15. Another way to do it is to say that instead of 180 degrees, I have 75 degrees less than 180. So I have 105 degrees here. So I have 360 plus 105, another way to think about it. So adding that or putting that together gives us 465 degrees, and it's in a clockwise direction, so put the negative symbol in front. Our terminal side ended up in quadrant 3, so we're done with that one. This time we're going to go backwards from what we just did. Given the angle measure, let's sketch it out and state the reference angle. So 420 degrees is a full rotation, 360 plus another extra 60 degrees. It's a positive measurement, so we're going to open up counterclockwise. So opening up counterclockwise from our initial position, going a full rotation plus an extra 60 degrees puts us approximately right there. As long as you include this reference angle right here, we know that regardless of where you drew your ray, we don't have to check it with a protractor. We know that we meant to make it 60 degrees right there. Part B. A negative angle, we know we're going to open up clockwise. We're going to go 270 degrees. Well, if you think about your quadrants are each 90 degrees, then that's just finishing up 3 quadrants. So one quadrant, second quadrant, and the third quadrant. That puts us right on the y-axis. So we can't state a reference angle, although you could think it's 90 degrees, but the definition of a reference angle is that it's an acute measure, so it's got to be less than 90. So we often don't call 90-degree angles reference angles. We could just say that it lies on the y-axis. So again, going clockwise, 270, ending up on the y-axis. All right, there is another way to measure angles besides just degrees, similar to how we can measure lengths using a variety of different units. We could do feet, yards, miles. Well, angles have a few different ways that we can measure them. One is degrees, and another one is called radians. So let's define a radian. There's a cool little graphic we can check out here, in addition to that definition. If I have a circle with a given radius, and I take that radius length and I just lay it along the arc, so this arc length is the length of the radius, well, that angle that's created is called a radian measure. It's equivalent to 1 radian. And if you break up your circle into groups of radians, we see that a half circle is a little bit more than 3 radians. It's actually pi radians. And if a half circle is pi radians, then a full circle is 2 pi radians. All right, so again, a radian. That's the measure of the central angle created when the length of our radius is the same as the length of our arc. That intercepted angle there is equivalent to 1 radian. Well, we know another formula that we can use to kind of make sense of this. We know that the circumference of a circle is twice the radius times pi, or 2 pi r sometimes. So if our arc length and our radius are the exact same, well then, we must have a circumference of 2 pi. And so if one full rotation or one full circle is 2 pi, then what we can do is we can break that up into fractions as we go around the circle. So a half of 2 pi, or a half circle, would be 1 pi. So here we can see 180 degrees, or a half circle is equivalent to 1 pi. If I cut that in half, take half of a half circle, we get 90 degrees, and half of pi would be pi divided by 2. So there's the radian equivalent of 90 degrees. If you cut that in half, in a sense breaking up this first quadrant into 2 halves, then half of a half is a fourth. So 45 degrees is equivalent to a fourth. Now if we count around the circle in terms of fourths, here's 1/4, 45 degrees. Double that, that's 90 degrees. I have 2/4, or a half. Add another 45, that's 135 degrees, or if I add another fourth to 2/4, I get 3/4. And if I add another fourth, I get 4/4. That's equivalent to 1, or 1 pi there. Adding another fourth gets me to 5/4, equivalent to 225 degrees. Adding another fourth gets me to 6/4, which I can reduce to 3/2 pi. Equivalent to 270. So I'm at 6/4. If I add another fourth, I get 7/4. That's equivalent to 315 degrees. And if I add one more fourth, I get 8/4. 8/4 is the same as 2. So a full rotation is 2 pi. So another thing to think about is we could break up our circle into halves. We could break it up into fourths. Those are called the quadrantals. We could also break it up into intervals of 45 degrees. Another thing we're going to do later on, just to give you a heads up, is we're going to break it up into 2 more intervals. We're going to break it up into sixths, or in other words, every 30 degrees. So to get all the way over to the other half of the circle, that's going to be 6 parts. 180 divided by 30 is 6 parts. So we're breaking this up into sixths. So we'll be counting around the circle in terms of sixths. Another thing we can do is we could double that and get 60 degrees. If I have a sixth doubled, or a sixth plus 1/6, that's 2/6. That's the same as a third. So 60 degrees is equivalent to pi over 3. So I could break up my circle into groups of 3. If I divide 180 into groups of 60, that's 3 parts. So it takes me 3 pieces of pi to get a half circle. So we'll do that a little bit more in some future videos. For now, what I want students to focus on is just trying to recognize some of these basic angle measures and their equivalent radian measures. The sooner you start studying and recognizing those, the better off you're going to be. What if we have angles that are not quite in those intervals? Well, we have a way that we can determine or convert from degrees to radians. If I have an angle that's in degrees, well, how many radians is that? Well, let's go back up here and let's see that we said that 180 degrees was 1 pi, and we can use that to get our conversion. So if 180 degrees is 1 pi radians, to solve for 1 radian, I can just divide both sides by pi. So 1 radian is equivalent to 180 degrees divided by pi. So if I take the reciprocal of that, then I can convert them to degrees or back to radians. So here's how we do it. Degrees to radians, we're going to multiply by pi over 180. And to go from radians to degrees, I'll just do the reciprocal of that, and I'll multiply by 180 over pi. Maybe thinking like, man, that might be confusing. I might forget which is which. So I'll try and give you a clue, a little trick that you can use to remember which is which. If you don't like this fraction form of 1 radian, well, you can do that division. 180 degrees divided by pi gives you approximately 57.3 degrees. And so 1 radian, you can see up here, is about 57 degrees. More than 45, but less than 60. But that's rounding. That's less accurate. This is the most accurate form of a radian. All right, let's practice converting. Going from 45 degrees to radians. 45 degrees is one of those special angles that we're going to want to know. Here's how we get to pi over 4. To go from degrees to radians, we're going to multiply by pi over 180. So 45 degrees divided by 180 degrees, you can think that the degrees cancel, and that leaves us with pi radians. So 45 pi over 180. We can reduce that. 45 over 180, we could divide top and bottom by 45. That's the greatest common factor, and get 1 over 4. You can put the pi on top. You can put it off to the side on the right, but never put it in the denominator. Part B, negative 450 degrees. Different direction of our angle here. We have degrees, we want to go to radians. We're going to multiply by pi over 180. So I like to remember that I put the 180 degree on the bottom or the denominator. That way I cancel my degrees. And I'm left with a pi term, and radians are generally in terms of pi. So 450 over 180, I could cancel the zeros or divide by 10 and be left with negative 45 over 18. Common factor there is 9, so I can divide by 9 and get negative 5 over 2, or negative 5 halves, pi radians. Typically, we don't write our radians in decimals. We tend to keep them in fraction form. All right, let's go backwards. Let's go from radians back to degrees. So given negative pi over 3 radians, if I want to go from radians back to degrees, I'm going to multiply by 180 over pi. The reason why is radian is typically in terms of pi, and so if I am dividing by pi in my conversion here, that'll help me cancel my pi terms and leave me with just degrees. So multiplying straight across, we get negative 180 over 3. 180 divided by 3 is 60, keep it negative. So 60 degrees and pi over 3. Another one of those special angle measures that we want to memorize. One more time, 8/3 pi. We're going to multiply by 180 over pi, try and cancel those pi's. 180 divided by 3 gives me 60, so I could also reduce that first before I multiply. So all that's left is 8 times 60, which is 480, and we're in degrees now. All right, now that we've practiced radians a little bit, let's go back to that first set of questions that we did, but this time we're going to do it in terms of radians. So this is really where we need to get to eventually, being able to deal with these angles not in degrees anymore, but rather radians. All right, so given this reference angle in this diagram of pi over 6, what is the measure of our angle here as we rotate? We are doing a full rotation. So this is going to be helpful to think in terms of fractions, which is a little tricky for some people. We said that 2 pi was a full rotation around a circle. So I have 2 pi plus an extra pi over 6. So in order to add those, I need common denominators. So I'm going to think about my full circle in terms of 6. I need 12/6 to be equivalent to 2. Now that I have common denominators, I could add the numerator. 12 and 1 gives me 13, and keep my denominator the same. Keep it in terms of pi. Lastly, think about the direction of your angle. I sometimes make this common mistake myself. Try to pause before you move on to the next question and ask yourself, what direction did this angle go in? So since it's going clockwise, make sure and include the negative in front of your angle measure. This angle ended up in quadrant 4. That's the side the terminal side lays in. One more time, part B. Given this is 3/4 pi, let's try and figure out our reference angle, that angle between the terminal side and the x-axis. Since a half circle is 1 pi, and a half circle in terms of fourths would be 4/4, well, we must have an extra fourth missing right here. So our reference angle is 1/4 pi. So our angle is doing a full rotation, or 2 pi, plus an extra 1/4 pi. Since we're in terms of fourths, let's convert our full circle in terms of fourths. So instead of 2 pi, we have 8/4. That's equivalent to 2. Now we can add 8 and 1 together, giving us 9/4. And check in one more time to see the direction. Opening clockwise makes us give it a negative angle measure. And one more time, it ended up in quadrant 4. Last thing, let's see if we can sketch it given radian angle measures. Negative 5/3 pi. Let's think about, is that a full circle? Well, in terms of thirds, a full circle would be 6/3, so I'm not quite a full rotation. I'm actually a third less than a full rotation, so I know my reference angle there is going to be 1/3 pi, pi over 3. So if I go nearly a full circle but stop, giving myself what is equivalent to 60 degrees left over there, pi over 3. By stating that pi over 3 in that reference angle spot, regardless of where I draw this line, as long as it's close, this is what I meant. It was negative, so we made sure and went clockwise. Here we have a positive, so we're going to go counterclockwise. We're going to go 9/4 pi. So again, thinking in terms of a half circle or a full circle. A full circle would be 8/4. That would be equivalent to 2. So this is actually a full rotation plus an extra fourth. So that leftover is my reference angle there. Go a full rotation plus an extra half a quadrant. That's pi over 4, or 45 degrees. All right, so there is rotational angles and an introduction to radians. Make sure that you practice identifying these special types of angles and their radian equivalents. The more you do that, the easier the rest of the semester is going to be.